Morning,
We'll
Dan.
get going in a minute. Looks like is that Taton for Oakland?
Yeah, this is Hong Liang. I will present Oculum's annual report. Hello, everyone.
Awesome, thanks. Well, we go in a few minutes and get through some intro stuff, and then we can get to that update. I know it's probably late for you. In fact, since it is particularly late for you, why don't we get going? And we'll kick things off here. Okay, welcome everybody to the Technical Advisory Council of the Confidential Computing Consortium. Today is July 23rd, 2026. Everybody is welcome to join into the conversation constructively today, just as you are to our open source projects and our other working groups. We all abide by the antitrust policy of the Linux Foundation, which you can find on their website. And today we've got Hong Liang on to give the update for Oakland. Then we'll talk about the agentic AI paper that we want to get started on. Alec will be around, I think, to talk about updates to our primary white paper. And then we've got some work yet to do on the first couple of blueprints. Did I miss any major topics people were expecting today? All right, I'm going to skip over roll call since we don't really have anything that we need to vote on. But this is the time of the meeting where if you have not been to one of these before and you want to introduce yourself to the rest of the crew, feel free to come off of mute and let us know how you like to be addressed and about your interest in confidential computing. All right, well, if anybody would later like to do that, you're welcome to introduce yourself at any point. Last time we had Renee run the show, so thanks for doing that, Renee. That meeting went very nicely. We talked about the Verizon project, some good continued progress there, very important in delivering different attestation standards and components with which to build verification capabilities. We also talked about the summit since we were just a couple weeks outside of the summit that took place in San Francisco. A lot of good content there, a lot of good opportunities to meet other people in the community. And then we did just, I think, a tad of discussion on the different white papers, blueprints that we've got going on. I don't have any announcements today. I don't know if anybody else had anything newsworthy that they would like to share. Looks like Renee's got the virtual hand raised.
Yeah, I wanted to draw everyone's attention to that MITRE proposal around continuous attestation. I know it was shared, I think, by Jens in the chat, but they're asking for feedback by, I think, August 31st. I was wondering if separately or together, folks would be interested in providing feedback. Maybe we can also ask Jens to present the proposal, or FrontierX or Invari who participated in the writing.
Jens?
Yes, if I may chime in. Sorry that I'm not on camera. You can hear my voice. I feel a bit awful today. But yes, I shared it. There is a public review window, and we would be super happy about any feedback. I did get in touch with Mike on presenting this to the CCC. I will have Dr. Spina from MITRE and Jason from Invari come with me. And we would be more than happy to present this in the CCC and discuss it openly. It's a public review, so it's not a final framework or anything like it. It's a for public review. This is exactly the reason we would love to have the CCC in whichever shape or form contribute, give feedback. After that, it will go in a second stage. It's lined out in the framework. And yeah, any thoughts on timing? We do follow a very narrow path that is been given to us by MITA because they want to push this framework forward. And it works relatively fast within that institution right now. So it might feel a bit short as a window. Was published in early July, so it's 7 weeks. But I'm already asking them if we can extend it maybe for a month. But any feedback, have a look. It's a lot to read. But any feedback we would very much appreciate.
Yeah, it's on my reading queue, so I look forward to reading it. I think given that time frame, the next meeting would be ideal if you think you'd be available 2 weeks from now.
Okay, yeah, more than happy to get that to Dr. Spina. Let me try to set this up. I will be in touch separately then. Cool.
Okay, great. I'm going to pencil you in.
Perfect.
All right, great. Any other announcements from the community? Okay. Looks like a few people just joined, so you haven't missed much. We're just kind of getting underway, got through announcements and getting into the main agenda. The very first thing that we've got Hong Yang on to talk about Oakland, so I will stop sharing and turn things over to him. Oakland, as I'm sure everybody is familiar, is a project that helps you run an existing program inside a confidential computing boundary without needing to make changes to it. Uses a libOS model, but I'll let Hong Liang talk about it directly.
Thank you, Dan. Thanks for the kind introduction to Oakland. Let me try to share my desktop. So can you see it? Can you see the slides?
I sure can.
Yeah. Everyone. Hello, everyone. My name is Hongliang Tian. I will present Oakland's annual review. I used to be ANT Group's representative for CCC, but as I shift my focus to from TE to other areas, I have been quite involved in CCC or the TSA meeting. So this is in my first time for quite some time attend the TSA meeting. Glad to be back. So this is going to be a brief annual review for Oakland. For those of you who are not familiar with Oakland, it's very popular, one of the most popular libraries for enclaves. For example, Intel SGS is Linux compatible, supporting multiprocess, written Rust. And it has attracted some real customers from big techs like Ant Group. So the project stated update will be brief because, as you know, enclave such as Intel SGS is going to use less than the confidential VMs. So developer interest in and users' interest in using enclave libraries is decreasing. So there haven't been quite some new development in Oakland for about a year. So I think Oakland project is approaching the end of life, and we'll change the status of this project to emeritus this year. No budget usage. Okay, so this is the key message. Okay, and so this I'm the I'm the founder of this project, so I feel some kind of sad to announce that Oculum is approaching its end of life. But there's hope. There's hope. There is a successor to Oculum, called S3NS. I've just gave a very brief introduction to this project. So S3NS is it's like Oculum is an OS kernel, but S3NS is a general purpose OS kernel, and its design is written in Rust, and its design make it a more secure option than Linux, so it can be used for TE and beyond, and it's open source. S3NS is the what we call frame kernel. It's the first frame kernel. The frame kernel architecture promise the speed of a monolithic kernel and the security of microkernel. As you can see from the architecture on the left, the entire kernel is written in Rust, but is logically partitioned into two parts. One part is what we call the privileged OS framework. Its name is OSD, the standard library for OS development. Only in this part in OSD that the kernel developers can write in unsafe Rust. So the entire memory safety of the kernel it can be determined by this part, and it's very small. And we condense or limit all unsafe Rust into this part, and it exposes high level safe Rust APIs, so that most of the kernel logic, the green part, like system call handling, process management, task scheduling, inter-process communication, virtual memory, page cache, file system, network, and most importantly, device drivers can all be written in safe Rust. So so with this architecture, we can be sure that only a very small portion of the kernel is responsible for the kernel memory safety. So it's very, very memory safe. And because the entire kernel reside in the same address space, there are no actual hardware isolation. So it can communicate as fast as communicate as efficiently as Linux kernel. So this is the why we build this new kernel. Is it can support over now 240 Linux syscalls. It's quite mature. Okay, and we have a paper published. You can see the paper for the technical detail. So why I present this kernel on the CCC TAC meeting? Because S3NS can be used as a more trustworthy guest OS for confidential VM. In fact, in our latest release, S3NS can be used directly by the confidential container project as the in-place replacement for Linux as the guest OS. Because S3NS is more memory safe, is by design, it is immune to most memory safety based IAGO attacks. So S3NS by design and implementation is more secure than Linux. So this is a viable option for confidential VMs. Okay, so that's all. This Oculum update and the successor of Oculum. Thank you.
Well, that was great. Also, a little sad for me to hear that Oculum is approaching end of life, but I think any project would be fortunate to be as influential as Oculum has been. Clearly groundbreaking work with the libOS design and some early adoption in the confidential containers project when we had SGX-based container isolation mechanism over there. It was like a nice cousin to Gramming. So
Thank you,
great
Dan.
project.
Thank you for your kind work. Appreciate.
Well, thanks for all your work on it over the years. It's also I think, testament to the maturity of the Oakland team and to yourself to recognize the timing to do the shift to emeritus. That can be a difficult decision to make, so appreciate the proactive nature of that. And then Astrina sounds very exciting. Is that something that you've presented over in the Cocoa community?
Not yet. We have a in-house custom version of Cocoa. Because as soon as because to be full Linux compatibility is very hard goal, because Linux has too many functionality, even just for a specific use case like container containers. So we have some modifications to Cocoa, but eventually we should be able to use unmodified Cocoa and just replace Linux with Astronas. So eventually we will approach Cocoa community and present Astronas.
Great. Well, I'm sure they will be excited to hear about it.
Yeah, I hope so.
Questions, comments from the rest of the TAC? Go ahead, Alec.
I'm just curious, is there any interest in having Astrolina be a CCC sponsored project? It feels like it's, within our space of interest. I was wondering if that was going to be the surprise finish to the pitch there.
Oh, that's a good question. One lesson that I learned from Oculum is that the users want Linux compatible, but a kernel, a secure kernel just for a niche market will never attract enough developers and customers to have the kind of momentum to drive this project to match Linux performance, functionality, security. So if we want a more secure Linux compatible OS kernel, we have to be general purpose. We have to cover a wide range of use cases. So that's why we position Astronas as a general purpose kernel for cloud, for desktop, for TEs, and much more. So I think Astronas is go beyond what a CCC, the scope of CCC. Yeah.
Help me understand, if you don't mind, and sharing your knowledge. What are the use cases for a non-confidential Linux kernel that is, using your words, more secure than the standard Linux kernel? Is the advantage that it's written in Rust and is therefore memory safe, or are there other advantages that I'm not seeing?
Yes. To eliminate memory safety bugs from OS kernels once and for all. That is one of our main goal. Yeah, and this benefit applies to all use cases, right? Yeah, and another goal is that we want to modernize OS kernel design, because for Linux you have to cover a lot of outdated hardware, such as you need to cover 32-bit CPU architecture. But for Astronas, we only target 64-bit modern CPU architecture, and we can make design decisions that are radically different from Linux. For example, we won the best paper awards of ISO-SP last year. The paper is about a new a radically different design for the memory management unit, for memory management subsystem to achieve much higher CPU scalability. By using a new language and build from scratch, we can make more even better design decisions to achieve security benefits, performance benefits, even development more development friendly. So it gave us a new language, and we can think in a new way to get more benefits beyond the safety.
Got it. But this new MMU that you're designing is going to be backwards compatible with any 64-bit Linux
Oh,
code.
sorry, it's not MMU. It's a memory management unit. It's memory management subsystem of the kernel. It's not a hardware. It's the kernel
Okay.
subsystem. Yeah,
I got it. Okay.
So yeah,
And you're aiming to make it backwards compatible so that existing Linux workloads will be able to be compatible with this new memory management unit.
the system layer, all user facing API are Linux compatible. So it's only internal changes. I mean, we kept in the kernel's user facing interface intact. We only use a different implementation for memory management.
I get it. Yeah, I forgot. This is LibOS. So this will be built with this new library that you folks are proposing.
Sorry, it's not a LibOS.
I think I'm a little lost. I'll go back on mute and let Mona go.
Okay, it's not LibOS anymore, because for CVM or VM or bare metal, you have a real kernel space. And this kernel running in the kernel space, it's not a LibOS. It has a hardware isolation from the user applications. It's not LibOS.
Got it. It's not in the application space. It's in the kernel.
Yeah. It is not.
A quick question, Tian. One is, you do support multiple applications running on this kernel, right? It's not a...
Yes, actually, this new kernel has implemented over 240 Linux system calls. That is a large number. Actually, we can run a distribution.
No, you can support multiple address spaces. That's all I was asking. Like, it's not just, you can run multiple applications on top of this. You have the MMU. Yeah, no,
yes,
a bit unlike Grameen TDX, which this is just a little bit going back to Alex's question. Like, while Grameen can also run in a VM, we chose to keep it single application. So it's a bit like a unikernel. Yeah, okay. It's not a unikernel. This is a multi-kernel.
So okay. So you want to compare Astronas versus Grameen TDX?
No. I understand you. Astronas, you're going towards a full kernel, but that's fine. That's all I was asking. But then another comment I have, you are trying to aim it to general purpose beyond confidential computing. But then your threat model is different, right? The threat model will be different when you're running in a CCVM versus when you run in a I can go to the video as well. When you run
on a
untrusted host versus trusted host. So your design choices will be completely different. I don't understand how you can have the same kernel running in a CC environment versus not. That's the whole point. If you think about Grameen TDX, Linux, we believe Linux is still not the right choice. It's the easiest choice, but it's not designed. Linux was designed by trusting the host in mind, and we're throwing it in confidential VMs, right?
But let's draw the analog. So Linux is general purpose OS kernel. It can run on bare metal, virtual machine, or confidential virtual machine. Right. So the same kernel can run in 3 different settings. So why not, as Linux, a Linux compatible kernel can run in 3 different setups?
Yeah. So you make the same mistakes. That's what the whole point. I'm saying Linux is a general purpose kernel. It was designed to run in an environment where you trust the host. You build these systems secure from all the way from the bottom with everything in your chain. Then we have confidential came around, and we said, oh, we don't have to trust the host, but we can be running in this environment where you can provide certain guarantees, which is great. And I just think Linux wasn't designed for it. You need to design a kernel from scratch. Estrinas is one of them, and I was actually thinking you were going towards that, where you don't trust the host, your interfaces would look different. So yeah.
Yeah. I think okay. This is a good point, and I can I share one more slide to answer your question better?
Of course.
Okay, so the most interesting part of this new architecture is that we want to achieve what we call soundness. So it means that so for whatever Rust code, safe Rust code.
I'm not seeing a slide. If you're trying to share a slide, it doesn't seem to be coming through for me.
Yes,
Same here.
I don't see anything.
It did briefly, and then it disappeared. Yeah.
Let me try again. Can you see the slides?
Not yet, and you know how lost I am, so I really need this slide.
Can you see it? Can you see it?
No, I can't either.
It should be sharing my desktop.
It's
You might want to try.
it says like it started screen sharing, but it hasn't actually painted your screen yet. So
You might want to try just sharing the specific application rather than your whole desktop. Sometimes that has formatting issues.
Okay, let me try again. Try again.
There it is.
That's it?
Yep.
So I think one of the most interesting part of this new architecture is that we have very challenging design job, which is that for whatever safe Rust code that one can write, we must ensure that so these safe APIs cannot be misused. So this is called soundness. So the soundness that for our this is our OS framework. So for whatever kernel that may be written on top of this OS framework, as long as it's safe Rust, and despite of the timing that the code may be executed, and despite of the arbitrary inputs that the code might get from the environment, from user space, or from outside from hardware, from any devices, that we must ensure that the kernel memory safety is guaranteed. So if we can guarantee this kernel safety regardless of the environment inputs from environments, this implicitly includes resistance against malicious inputs from Yago tags. So in this architecture, we only trust the red box. This is the framework, and the Rust compiler, and the CPU, the main memory, and some essential devices like I/O controller, interrupt controller, and I/O MMU. For TE, we trust the TE protection is won't be breached. So we do not trust any peripheral devices. We do not trust any peripheral devices or its inputs. So for bare metal environments, for VM environments or CVM environments, for all these settings, our threat model we do not trust any peripheral devices. So this makes this design immune to Iago attacks for CVM. So the same threat model. Because if we have to trust a peripheral device, like a peripheral device can, for example,
No, I understand. I'm not talking about peripheral device. I'm talking about the host OS, host Linux that you're running in a normal VM case, in a normal VM. In case of a CVM, I understand. That's exact. I was saying the threat model is different. It's okay. This is fine. You still have to think differently, right? The whole threat model is different for normal VMs versus CVMs. You said you would like to this is at least from my perspective, that is why I think Linux is not suitable for CVMs. While it's the most convenient, this is the most deployed. Users don't always want the most security. They sometimes just want convenience. Linux was not designed to run in a CVM. Yes, we've been trying to, like, for example, Google has done some work to minimize the OS. What is it called? Attested ACOS or something. Yeah. So that's fine. I think you are also probably doing work to run it in a CVM, CVM versus. So I just wanted to highlight that the threat model is different, and so your design decisions will likely be different unless you are designing it for the most restrictive model, in which case you're not going to be as efficient when you run it in a VM environment. That's all the point, right? But this is good. This is great work, by the way. I have to say this is great work. This is one of the things I've been wanting for us to move Grameen TDX to Rust. We have not done that. I think this is a great start, like for a new kernel, building it all in Rust. So yes, thanks for the update.
Well,
okay, since any more questions?
Hey, clearly a lot of discussion to be had here. This is a very interesting topic. I will kind of double down on Alex's offer that the CCC could be a good home for this. I think that you're right that it might make people think about it narrowly, but I think as the consortium gets into this next generation of confidential computing, where we're looking at multiple devices providing TEs, and it's no longer like CPU centric or library centric, that we are going to be expanding what we've traditionally thought of as appropriate for our project portfolio. So think about whether you could get more eyeballs on this project by bringing it into the consortium and being able to make use of the advertising that we have available. And if that sounds attractive to you, let me know and we can follow up offline.
Yeah, great. Thanks for invitation. We'll think about it. Thank you, Dan.
Great. So I think technically we are supposed to vote on emeritus status, like any status changes. That's most meaningful in an emeritus case where we've lost track of the maintainers and we need to make a decision on their behalf. So I see that we have quorum at the moment, so I will just make a motion to move this project to emeritus. Is there anybody who opposes that motion? Going once? Going twice? Okay, great. It is, we've covered our technicalities here. All right, the next thing on our agenda is taking a look at our primary TAC white paper. Alec had observed that it has aged a bit and we need to bring it up to speed with the current state of things. So I will let Alec walk us through his thinking and where he's at with that.
Sure. One quick thing, Dan, just while we're thinking about papers in general, have we gotten full approval to go with the blueprint papers that have been proposed and have kind of been percolating through the TAC? Like I think the
So
blueprint
we
A,
put
B, and C.
So the 3 degrees paper is approved and put online. The C paper we voted on, approved, it went into layout, and I don't know if it has been posted yet. Maybe Renee or Michelle.
I think we were
What's the
waiting
latest?
on author attribution approval to finish up for one of the authors or editors, but it's almost there.
Yeah, okay. I thought the last email I saw from him from Mingshen that it was okay.
Yeah, I recall the same. So I'm
I
not sure
Okay,
where
I'll double
all
check. I
about
thought he
this.
had said that he thought it would be okay, but it was going through approvals. But I will double check just to be sure. I didn't want to push it through without being totally confident that there was approval.
Yeah, I think you might be right that his wording was less than concrete. So, but yeah, so that one should be going up, and then we'll have some discussion in a little bit, Alec, on A and B.
Awesome. Awesome. Great momentum. Let's see if we can keep it going. Let me share my screen. Hopefully I can get this to work. Let me know if you can see it.
Yep.
Yeah, I can.
All right, cool. Everybody can see it okay?
Yep.
Yes.
Awesome. All right. So this is the technical analysis of confidential computing. I think it was the original paper, white paper published by the CCC. I just want to call people's attention to the date in which it was published. That's we're coming up on our 5-year anniversary. So this paper needs to be kind of gone through. I've having reread it, it's held up pretty well. I have to say the original authors deserve a lot of credit for writing a paper that was kind of future proof. Um, my goals were to there were some internal inconsistencies. I want to fix the obvious internal inconsistencies. I wanted to shorten it a bit. So I'm going to suggest moving some things to an appendix. There were a couple of example use cases of what a side channel attack is that ran to, a page and a half. And I think by now people understand what side channel attacks are. And I'll just reference them in the opinion. And that kind of shortens the paper a little bit, the operational parts of the paper. And then the other thing, I think the only thing that's going to be controversial is I think the CCC agreed that attestation is required in order for an environment to be considered trustworthy. The paper was written right after that decision was made, and so there's some internal inconsistencies where attestation is considered not a requirement, and I moved that up to make it a requirement. So we can talk about this.
So maybe just one point on that. The latest draft is version 1.3 published in November 2 of 2022. So you might be back one level.
Yikes, okay. Well then let's just do this because I was having trouble with the new web page. So let's just start there. So I went to the new web page, and I love the new web page. But I was used to seeing resources and then white papers. So I clicked on resources and it took me to here. And so then I go to read technical specs, read more documentation. And that's where you get the list of papers. And then I came down here to technical analysis, read the report. Let me just go up. November of 22. So, okay. Somehow I made a difference. Let me just see if attestation is changed in there. And I apologize. This will only take a second. And then we'll go back to the paper that I have. I'll just do a quick search for
I
attestation.
also, by the way, had a little problem with the new website layout, finding the documents. So everybody is welcome to send feedback into the outreach channel, and they're happy to tweak things. It was a nice revamp, but it does make it a little harder for us to find things when we're used to the old way.
Great. So let's just see something here. Properties. Maybe I can just go here. No, I can't go here. But now I know it's properties. Oh, finally, this thing found it. Yeah, see, here's maybe a section. It says properties, data confidentiality, data integrity, and code integrity. And then it says depending on the particulars of a specific T, it may also provide attestability. I think that is internally inconsistent with our definition of a T, which is a hardware-based attested trusted execution environment.
Yeah, I think you're right. I want to say that Trust Zone maybe did not have attestation, and when this was first written, it was meant to be able to encompass that. But anyway, regardless of the historical reason for it, I think you're right that we want to make sure that that's not an afterthought.
Okay, so in my edits, I have promoted attestability to the properties that are required. Trusted execution environment is defined by the CCC following common industry practice as an environment that provides a level of assurance of the following, I'm going to say 4 properties. Data confidentiality, data integrity, code integrity, and attestability. So that probably is the most controversial thing I'm going to propose changing. And let me just share this with the folks here. I'm going to go to the chat.
Do you actually want to maybe take these changes that you've done and apply them to version 1.3 and then
yes, I will do that. But what I want to do is, while I have the tax attention, I kind of want to review the changes. And if everybody, and unless I get some strong pushback, I will port these exact same changes to the new version of the doc and sort of merge them back in.
Thank you.
Okay. So having gotten through the worst of them, or the most radical changes, I'm going to say these are just slight changes. I'm going to add some graphics that I think we've already gotten the terminology paper to show what the stack looks like. I'd like folks to post comments on layers of the stack that they would like to see represented in the graphic. Here is sort of conversation starter of layers. My goal for these layers is to have it be something that is just generic IT professionals and computer scientists will understand. Anybody who's familiar with VMs might understand. And If I'm missing any, I'd like for those to get included here. So when I put together the graphic, it's exhaustive. One thing that just occurred to me is, should we add um, container layer? I think that might make sense. And let
So,
me just, yeah, I
yeah,
was just going to
I've
pause here
got,
and ask, how do I get the kind of input from the tag that I think I need to get a sort of a final draft of this paper done in the next little while?
so I think after the live discussion here, if you can work with Michelle to get a globally accessible link that the community has comment access to,
I
we
think this is it,
can.
Dan. I I think obviously I need to merge in the new changes, but this is living in the
Mhm.
link that Michelle provided, unless I messed up and posted the wrong link.
Okay, if you already got this, that's great. Then I think we've got a 2 week period then between this meeting and the next for people to come in. And it's not like this is a wholesale new document. So people, it seems like a very reasonable expectation that people can get feedback in by the next meeting. And then we should just be able to vote on these surgical changes. The diagram might be more work, but I don't want to I've got opinions on that, but I want to open it up to other people before I start expressing my thoughts there.
Anybody want to go and share the thoughts based on what they see on the screen here? All right, Dan, hit me with it.
All right. So one of the main things I was trying to do with the 3 degrees paper is people think about confidential computing kind of focused on what is the stack that is on the confidential computing host. But most of the integration work we have to do are on back-end systems that are relying party systems for the confidential computing node. So I'm not in love with any of the pictures I came up with for the 3 degrees paper, but that's the exact kind of problem I was trying to tackle, is that thinking of this like a stack is limiting and it's incomplete for people to understand what they need to do.
Give me an example of the kinds of things I should be looking for in the 3 degree papers that's absent from this stack diagram. Are you thinking of like the HSM? I'm drawing a blank. I'm trying to
Yep.
remember.
Yep. So specific example would be a key management server that understands attestation. You could have an attestation verification system that's independent from that or integrated with it. Then there's really any variety of systems that could be relying parties to a confidential computing node, but you at least need a point in the overall solution that can interpret the attestations and whether or not they meet a policy.
Got it? Okay. What about multiple hardware components? Um, GPU, I think we need to kind of go ahead and add that there so that folks understand it. And then dare I include the NIC? That kind of gets us into public cloud land. And this paper has studiously avoided, well, that's not true. There is tangential mention of CSP uh, issues. I'd like to include the NIC as something that is public, but that's because my background is from the public cloud. How do others on this call feel about me including multiple hardware pieces, some potentially, or in this case, I want to introduce the concept of a trusted hardware component that is operated by a public cloud service provider so that people can start to think about the, the shared responsibility model in terms of confidential computing. Any strong objections to that, or would you be willing to look at a draft of what that looks like and then withhold judgment until you've seen the draft?
So I missed 5 to 10 seconds of what you said because my screen froze. So if that was directed at me.
Yeah, I don't think it's directed at you. I think based on where you're, and I see your screen still frozen. Dan, I'm not sure if you can hear me. I'll continue as if you are. I think based on where you're sitting today, you'll be fine with including multiple hardware components because you're now looking at GPUs. I similarly would like to include hardware components like the NIC. Did that come through, or am I losing? I see Renee moving in real video time, but it looks like Dan froze on me.
I can hear you. You're still alive, and
Okay, cool.
I vote for what you suggest here. Um, Maybe in a kind of a hint or in a way that is consumable for new readers, mention the need to have the accelerated, improved interaction between those devices. Um, Today we have the bounce buffer, but we want to have it implemented by the hardware and not by the
Yeah.
software.
Actually, this is Syam. I have one comment on that. Rather than calling it a GPU or NIC, can we talk about a functionality like, hey, if it's a DMA device, or it can do like calling them like which functionality we would like to be considered rather than calling a device, because there's so many other devices, multifunction devices. They do similar things as GPU, but they don't call them as a GPU. So it's better to call it a technical functionality rather than calling a category.
I love that. Let me probe you for words. So what I'm hearing you point out is that what's salient about these devices is that they have DMA access to T memory. In other words, they can alter the contents and view the contents of memory in the T and are therefore part of the TCB. And that's the point that I should call out. Did I take your point
Exactly.
correctly?
You put it much better
Understood.
than I. Yep. Thank you.
I stole your words. Thank you for volunteering them. Okay, that's a great point. Okay. Excellent point. I'm gonna go ahead.
Like it's not just the DMA thing, right? It's also that some of the computing that is happening is also getting computed on those devices, and they are also that has to be confidential as well if it is part of the same TE. Right. In the case of GPU, yes, there's computing happening, but there could be other devices which will be contributing to the computation, which is part of the main processing.
Got it. So these devices, I'll just point out here, your point is these devices can read data from T memory, perform computations
On behalf of the T memory, yeah, on behalf of the TE.
in their own hardware,
Right.
and write the results back to T memory. Did I capture your point correctly, do you think? Obviously, I'm going to have to turn this into words, but your point is that these devices read data from the T, they perform calculations, and then they write the results of those calculations back to pages that are assigned to the T.
I think
Did I?
yes, yeah. But is a third part needed? I mean, if do they have to contribute the results back to the TE memory, or is it sufficient even if they contribute a little bit of computation on for the
Well,
behalf on behalf of the TE?
maybe I'm misunderstanding your question, so I'm going to maybe overthink it out loud. Um, my understanding is that the way the flow works is the CPU and uh, part of the T will get data from, let's say, the file system or the network, and we'll store it in memory that's owned by the T, that's in a page that's assigned to the T. Then we need some analysis done that's optimized for GPU processor. And so we send instructions to the GPU and say, dear GPU, please do some, matrix math calculations based on the memory that I just loaded from the file system. The GPU reads that data from the memory assigned to the T that was populated by the CPU, and then it does a bunch of calculations. And then the results of those calculations kind of have to be stored somewhere in order to be useful. So the GPU then writes those results back to pages that are also owned by the same T. That's the way I mentally understand it, but I'm open to corrections.
Yeah, I think I agree with all of that, but the last part that you're mentioning, that the results have to be written back to the T memory. Is that a necessity? The results need not be written back. It can be kept locally within the device and maybe shared with the rest of the world, but it is doing the computation on behalf of the T. That's the point that I'm trying to make.
Okay, understood. I'm just going to say here written. I'll just say possibly write the results. In the case of a network interface card, a smart NIC, then certainly the point of a network interface card would be to retrieve data from the network and write it to memory that's assigned to the T. And so in that case, write access is sort of necessary in the case of a GPU. I don't understand enough about GPUs to know what they might do with the data um, after they've performed their calculations. So I think I've taken your point. Let me try and turn it into words and then we can review the words. Okay, so I'm going to do that. Those are just edits. Let's see, what did I do here? Okay, with the goal of decreasing the reliance on proprietary. Oh, I just added the term closed source software. We just said proprietary software before. The four properties. And here's another diagram that I want to include. In the context of confidential computing, unauthorized entities could include other applications on the hosted operating system, hypervisor, and system administrators. This is from the original paper. Service providers and the infrastructure owner. So I think what I want to do is add a diagram that kind of shows what this stack looks like in public cloud where there is a host operating system and a hypervisor and service providers and infrastructure owners that are not the individual customer that owns the T. So I'm going to include that diagram. And I think we've got those diagrams already from other documents, and I'll just include them here. We've already talked about moving attestability up. And I think the rest of this, yeah, I just changed the wording a little bit to kind of reflect the way our views have matured over time. And then there's a bunch that I'm going to move to an appendix, and that's what you see down here. So with that, I will relinquish the floor. I don't know if our esteemed chair has made it back. But I think this is essentially what I'm going to do with this paper. Does anybody have any other suggestions they would like to add while I've got it open to fix it? Happy to listen to those suggestions, or just go ahead and propose the paper and see if we can get votes for it. Comments? No comments. Dan, are you back? Dan's back. I think this was a clever ruse on his part to get somebody else to be the rotating chair this week without having gotten prior agreement. So nice, well played, Dan. He's always a couple of steps ahead of me. Okay, I don't have access to the rest of the agenda, but Michelle, if you have access to the rest of the agenda and don't mind sharing the screen, or if you can provide a link to the rest of the agenda, I can try and get us through the rest of the meeting.
Yeah, I think we're actually almost at the top. That was the kind of work in progress. We went through the other papers and then the white paper, so it's really just wrapping up. The next meeting is August 6th, and Scott Rayner is the scheduled rotating chair.
Okay, well, if we've got just a few more minutes, then can I at least ask for a couple of volunteers to click on the link and confirm whether or not the permissions are set correctly so that people can see the comments and participate in this review?
Yeah, I
Yeah,
just did that.
I've just checked it. I can open it.
That works for me.
All right, awesome, fantastic. Well, then please read through it, leave comments. If you have no time for anything else, just take a look at the comments that I've left in review mode and reply to any comments that you disagree with of mine. That kind of will give me a lot of guidance on whether I'm heading in a direction that will lead to more votes of approval or will, drive away votes of approval so that we can get this thing updated and hung out there. This doesn't have to be the final version of the doc. This is just, version +1.
Alex, were you planning on migrating your comments to the latest version first?
Yep,
Or
I
should
will do.
we?
I will do that, and then I'll send an email to the TAC.
Okay.
And if we drop now, and it doesn't make sense for you folks to review this now, but if we drop now, I'll do that in the time we have remaining for this meeting.
Excellent.
Cool. Well, then I don't have anything else. Any other business? If nobody else has other business, we can adjourn the call now. All right, cool. Well, I'll give you back an hour of your day and look forward to seeing you folks in a couple of weeks.
Thanks, Alex.
Thanks, Alec, for closing us up.
Sure. Bye.
Thank you.